Lesson number 4, any software system that uses AI, even in a single place, is inherently non-deterministic. You have to accept that and make peace with it. It's very tempting to be impressed with the capabilities of the frontier models that indeed look like they're perfect for some use case, and then to be hopeful that that happens all of the time. But in production, it is a folly. Gen AI models, you ask the same question twice or 5 times, you won't get the exact same answer 5 times. Sometimes it gives a completely wrong answer, and your software system needs to be resilient to handle the non-determinism, and also when there's a complete failure to deal with that gracefully.
And in this case, we started to treat all of our subcomponents and model dependencies that we took just as dependent microservices, which means all of the conventional software engineering practices like retries, schema validations, and fallback mechanisms, etc., were applicable here. Many of the models these days, be it reasoning models or such, actually do produce structured JSON. So that does help us do a great deal of, great deal towards helping treat them as dependent services.
So these were some lessons. They are not all the lessons, obviously. And even if you apply all of these lessons flawlessly, it doesn't really mean you'll go from nothing to something in production in 4 weeks. That's not how it works. So in order to do this, you need a lot of other infrastructure on the hardware side, on the software side, and in different places you can do different ways. With Voltage Park, we call it our AI factory. What we mean is it is a place where the input is enterprise data, the output is actionable business intelligence. So in that example, the input was raw feeds from video cameras, the output was actionable, usable alerts. And to pull this off, all you need is models, the right models. You need software that consumes the models. You need infrastructure, hardware and software, GPUs included. Now, everybody has a factory. How's our factory different? These are a few fundamental ways where I think we are thinking about this in a different way. The first way is it is very use case driven. It's not about let's stand up capabilities that can solve anything. Let's start with one use case that you're trying to solve. Let's talk about what is the minimal footprint needed to get something working in production. So our factory is minimal. It is very modular. You add more use cases, you can add the other incremental things needed, both in the hardware and the software, to take that use case to production. One of the places where we are different is because we run GPUs at scale. We've become fairly good at it. So then by adding world-class software engineering capability, we end up with a stack that's very tightly coupled. And the simple reason why this matters is to drive down cost. If you don't do it, it is impossible to take the dollar per token down to its asymptotic approaching 0. So that's how our factory is different. From a customer's perspective, many customers don't have the time, patience, or expertise to mess around with all of this themselves. To them, it's very simple. It's one phone number that they call. They don't care how it's working. It just works. There's one phone number they call. And this thing scales. It scales from a few GPUs to any number of GPUs. The architecture is the same. So in this example, you could start with feeds from 50 cameras, scale that to 500,000 cameras. The architecture is exactly the same.